In this chapter, we will look at the rules of logarithms. Of course, we already have many rules for how to deal with exponents, and we'll find that the rules for logarithms mirror those. So let's go ahead and review those first. The first thing to look at is when you have something like x squared times x to the third. Notice that the base is the same. In both cases, we have a base x. Because we have a matching base, what we can do is add the exponents. That is to say, we have x squared plus third, which gives us x to the fifth. So whenever we have multiplication, we add the exponents. Of course, assuming we have the same base. Now, let's look at what happens when you have the same base and you divide. Well, you would just subtract. So you'd have x to the fifth minus 2, which is this x to the third. In the third case, we have a power to another power. So we have x squared to the third. So what do we do here? Well, a power to a power means you multiply. So this gives you x squared times 3, which is x to the 6. And lastly, what if we're looking at the nth root? One way to think about a root is in terms of an exponent. This n right here is referred to the index of the root, and you could switch this to its exponential form by keeping the base x, which is the radicand or the input to the nth root function, and then you have 1 over n as the exponent. Let's now use these to understand the rules of logarithms. So we have our very similar conditions that we're going to have that we're going to have that m and n are just going to be positive real numbers. Of course, this could be represented by a variable or some expression or even some other function. A is representing our base here. So again, keep in mind it's all about that base, that they are matching bases before you can do any of these rules. So we have the product rule. So notice in a concrete example, we have log of 3x. But we have the first expression is represented by m, and the second expression is our n. In general, we have the same base, in this case a, and we have log base a of m, and then you have log base a of n. Another way to think about it is each expression inside, or each term or value inside the input to the logarithm gets its own logarithm, of course keeping the same base. So we could turn this into log, which of course, since nothing's written there, is base 10. 3 plus log of x. In the second example, we have ln, which is again log of base e. So we have ln of 3 plus ln of 17. Again, notice the relationship to the rules of exponents, that when we have multiplication, it turns into addition. Okay, now we have the quotient rule. And if we're following the same pattern, if we want to write this in terms of two logarithms, you would have log base a of m minus, because of the quotient rule, log base a of n. It's important to note that whatever's in the denominator, that is going to be the negative logarithm. So here we have ln of 5 over 7. So this is ln of 5 minus ln of 7. And again, we could have computed ln of 5 divided by 7 using a calculator. And we'll find that these rules allow us to manipulate logarithms into something we could compute. More on that at the end of this chapter or section. And while the second one, we have log base 2. Notice the base is never changing, of x minus log base 2 of y. And the last thing we have is the power rule. So we have log base a of m to the r. Well, this r is in an exponent on the m. Notice it is, I said that it's just on the m, it's not on the whole log, and we'll talk about that in a moment in caution 1. So whenever you have an exponent, it could come down in front. So this is r times, because a power to a power meant you multiply, so the same corresponding rule applies here. Then we have log base A of m. So in this first case, this 2 comes down in front. It is a power or an exponent, so it becomes 2 times log base 5 of 7. And here we have an example of a square root. So we know that this is 2. If it's not ever written, we assume it's 2. So what I could first do is transform this into ln of x to the 1/2. And then using the power rule, that 1/2 comes in front, and you have ln of x. Thing to note, 2 things. First, log of x squared is not equal to log of x, all of that squared. On the first one, we are actually doing the square, so you square then log. So if you were typing this on a calculator, say x was 10, so you would have log base 10 of 10 squared. Well, you could simplify that. This is just log of 100, or you can use the cancellation property we discussed in the last section. It would leave us with just 2. On this one on the right, what we're doing is we're going to take the log and then we're going to square. So if you think about it, okay, we have log of 10 and then we square it. Well, log of 10 is 1, and then squaring the 1 is definitely not 2. So that's again why these are not equal. Another thing to be careful about is when you have an expression like log of x plus 1. Notice that in here we have an addition. We don't have an addition rule for logarithms because logarithms deal all with exponents and treating it as an inverse. So if you're thinking about that, exponents deal all with multiplication. So there is no addition rule here. In other words, what you say, you can't just distribute the log. There's no distribution, so don't ever do that. Again, if you just think about an expression, if you were to just say let x equals to 9, you would have a log of 9 plus 1, which we can easily compute. Log of 10 is just 1. And then that's not equal to log base 10 of 9 plus log base 10 of 1. Well, this is 0, but this is some decimal that's definitely not equal to 1. So 2 things to watch out before as you go through examples.